Yes, my dear students, the second session about the nuclear reactors. So, last session we discussed about nuclear reactor, how it will works, nuclear reactor, power plant, right. So, these two topics are the different topics, and this one is the nuclear reactors classification. So, the classification is depends on different parameters. The first parameter is type of coolant used, type of coolant used. Second classification, type of material, uranium material. Uranium material. Next classification is type of pressure, water pressure, type of water pressure. Next, type of power generation, These are the main classifications. So, coolant in the sense that already we know water is coolant utilized, water can be utilized, and helium can be utilized, helium gas can be utilized, and next one is a D2O. Okay. So, D2O lighter, D2O heavy, two classifications. So, one is water coolant, second one is helium as a coolant, next one is D2O, heavy water, light water and heavy water. Next, uranium materials, U233, U235, U239. These are the classifications. Anyone can be utilized. Next one is pressure water, that means low pressure and high pressure, LWR, HWR, low water and high water. So, here the low water, here the quantity. So, low water in the sense less quantity and heavy quantity. So, less quantity nuclear reactor and heavy water nuclear reactor, that is the classification. Next, power generation, that is low power, medium power and high power generation. So, these are the three classifications. So, nuclear classification. So, now here in our syllabus only the pressure, water pressure depends on water pressure. There are two classifications are there, low water and heavy water. So, here this low water is divided into two more classifications. So, low water is classified into two more classifications. The first one is pressure water reactor and boiler water reactor, two classifications. LWR, low water reactor, are classified into two categories. So, one is pressure water reactor, This is shortly it is called as the PWR, pressure water reactor. Second one is BWR, boiler water reactor. This is BWR, pressure water reactor, boiler water reactor. So, I think so you got one doubt. The doubt is, sir, in every reactor, in every nuclear reactor there is a boiler is there. So, why it is comes under the again the boiler water reactor? So, that is a doubt. So, in every nuclear plant there is a boiler is there. It is nothing but the heat exchanger. Boiler is nothing but the heat exchanger where the heat exchange is going to be takes place. In other side, the condenser is also called as the heat exchanger. So, that means higher to lower, lower to higher, two variant that we need to observe in the heat exchanger. So, here boiler water reactor in the sense there is no water supply is directly not going into the turbine. So, it is passed through the boiler. So, in other cases, so normal cases also the steam is generated in the boiler and it is connected to the turbine. That is normal cases. So here the boiler water reactor, in the sense there is no cooling agent, that means there is no separate cooling towers. So only itself it is generates. So that is about the pressure water. First classification is the pressure water reactor and the second one is the boiler water reactor. So let I am going to explain about the first case is the PWR, pressure water reactor. So here the pressure, in the sense fastly, that means low water. Actually LW are classified into PWR and BWR. So LW itself, it is nothing but the low water reactor. Quantity of the water is very less. This water is recirculated. So that is a smallest power generation. That means almost it is suitable for the 500 megawatts. Power is generated, this LWR, low water reactor, LWR. That is the capacity of the LWR, very minimum. So that means it is suitable for the land, almost suitable for the half acre or the 1 acre land is enough. Usually these nuclear reactors are located out of the city, out of the where the people are far away from the city. So this is located that area only, almost 100, 150 kilometers, 200 kilometers is the gap that the plant should maintain. So because once undoubtedly or unwantedly the things may be happen, it is not in our hands. So the accidents may not be give a signal. So that is in 1 minute or the 1 minute, 2 minutes, the accident may be takes. It should not give any cause. There is no reason also. That means, so any problem is going to be takes place to burst the entire the plant. So it will affect the almost 100, more than 100, 150 kilometers range. It will be occupies the radiation. So that's what it is located far away from the city. So this LWR is a smallest nuclear power plant. Okay. So that's what it can be generated only 500 megawatts, very smallest plant. Again it is classified into PWR and the BWR. Now I am going to explain about the PWR, pressure water reactor. See here, pressure water reactor. Water reactor. It is under the classification of LWR, low water reactor or less water reactor. Less water reactor, pressure water reactors. So this is the first case. Second case is the BWR. So now see the schematic diagram or the layout of the PWR. I am going to explain about the comparison between these two also, then you will get the perfect idea where it can be utilized and where this can be utilized. The first case is the pressure water reactor. See this one. Pressure water reactor. So turbine, steam sprayer, this one for cooling purpose. Pressurizer, steam inside, heater, so reactor, heat exchanger, coolant, pump, feed water, feed pump, cold water out, cold water in, alternator, condenser. This is the pressure water reactor. Low water pressure water reactor. Actually, it is the low pressure water reactor. Shortly, it is called as the. See how it will works. You please observe here. Totally, the water low pressure is maintained at a low water pressure. Water quantity is very less. So that water is again it is reused. Okay, with low pressure, the turbine will run. That is the entire water reactor will run. See here, these are the important components: reactor, and here the heater, steam, heat exchanger, turbine, alternator, condenser, feed water, pump. This is the feed water pump and feed water and coolant pump. Very smallest power plant. This one is the very smallest power plant because it produces only 500 megawatts power. Very smallest one. Now observe here. Why it is called as the low pressure water reactor? So the quantity of the water is very minimum and it is suitable for to generate the 500 megawatts less power. And now see the working principle how it will be starts. So where the water is pickups from the feed pump and sending into the heat exchanger. Before already the circuit or the work is starts at the reactor. So in the reactor the coolant pump can be supplied. What coolant? Reactor coolant. It is not the water. Reactor coolant. And it is supplied here where the pressure, very smallest pressure is generated here, and the spray which is comes into the heat exchanger. Okay, and heater it can be generated. Where heat is taking place? So from the reactor it is moves to here, and where the water is there, that water is heats at high pressure with high temperature, and it is enter into the heat exchanger, so it can takes place, and that steam is sending to the turbine. So the turbine is converts the steam energy, kinetic energy of the steam is converted into mechanical energy, and it is connected to the alternator which converts the mechanical energy into electrical energy. Again, whatever the steam is finished, that the duty of the steam is to rotate or to impact onto the turbine blades, and the turbine blades can be moved, the runner can be moves, and after that work is over, the steam is simply comes into the condenser for changing of its state. What state? That is vapor state to liquid state, and again it is fed into the feed water pump and it is connected to the feed water level and it is connected to the boiler, or it is nothing but the heat exchanger. So, this circle is moving. So, that is it is repeatedly takes place, so that the power will be output. That is about the low pressure water reactor. The difference of the normal reactor and the low pressure, only this area are the different. What about that area? The spray is a coolant, that means the spray will be act as a coolant to that particular steam. That means always it is maintained certain level of the pressure of whatever the steam is generated in the reactor. So, that is what it is called as the low pressure water reactor. And coming to the second case, BWR, boiler water reactor. Observe the difference between the pressure water reactor PWR and as well as the BWR. See the schematic diagram and you will get idea what the difference is there. So, this containing of only the reactor, turbine, alternator and condenser, only these are the parts. Turbine, alternator, condenser, feed pump, steam, water, boiling water reactor. Boiling water reactor, turbine and it is moving, and electrical power, electrical energy. See the difference. Here the difference is there is no heat exchanger, only the cooling water out, cooling water out, cooling water in, that is it. Okay. Simple design of the BWR, boiler water reactor. See, in itself, in the boiler there is a reactor, so it is directly connecting. That means the space has been reduced and some of the parts are also reduced. It is directly called as a smart power plant, nuclear power plant, smart nuclear power plant. That means the limited parts are there, but the main parts are there, that is the turbine, alternator, condenser and boiler. These are the important points. So, there is no direct indirect, that is the coolant supply is not there, and as well as there is no heat exchanger. So, all these all these components are avoided. Okay. It is designed this one because it is already comes under the LWR, low water reactor. The water content is also very less, quantity of the water is very less. With less quantity of the water, we producing the electricity. That is about the BWR special. So, now compare, I am going to compare these two. So, there is no heat exchanger, there is no coolant supply, there is no the sprayer, water sprayer. Simply it is design. It also, that is BW also generates the 500 megawatts power, simplicity, and it is not that much the danger. Okay. So, because So where the heat is generated, automatically the cooling is takes place nearby. The water is supplied and water is converted into steam. So whatever the heat is generated by the uranium or maybe the thorium or the whatever the material which is used in the reactor. So it is directly connected to the water, and the water is converted into steam. That steam is sending over to the turbine, and turbine is directly connected to the alternator, so that the power is rapidly produced by using of the PWR. So just you can see that the comparison. So the comparison is heat exchanger no, and the sprayer is no, and there is no coolant which is supplied into the reactor, that is also not there. So the water is used as a coolant for the entire the system. So that's what it is called as a smart type of the BWR, boiler water reactor. So that is about the next classification of the pressure water reactor under the LWR, low water reactors. Low water reactors are classified into PWR and BWR, pressure water reactor, and second case is the boiler water reactor. So why it is called as the boiler water reactor? In the sense, entire the reactor is in the boiler itself. So that's what it is called as the boiler water reactor. With this I am going to conclude this classification.